page 2 of the review. This is the second video. On page 2. Okay, let's go through this real quick. Now, one thing on this first one we need to notice is we have something raised to the 0 power. So we can go ahead and take care of that now. Negative 9x to the, or actually I would hold on just a second. Okay. Once again, I would take care of the exponents first. I mean the coefficients first. Okay. Now multiplying, I'm going to take my calculator. I have negative 9 times 2 times negative 5. Okay. That's, sorry, there's a bell. That's 90. So we have 90. If we look at it, why is it not negative? We have two negatives. Two negatives, it's even, it becomes a positive. Okay, now let's just add the exponents. Okay, the like base is x. Okay, 0 plus 3 plus 2. Okay, 3 plus 2 is 5. So we have 90x to the 5th. Okay. On the next one, we have 6a to the 7th b to the negative 2 power. See the negative exponent. Let's move it. Let's make it positive and move it to the bottom. So we have 6a to the 7th all over b squared. Okay, and that's as far as we can go. Okay. Now, the next one deals with several rules. First of all, we're raising a power to a power. Okay, so now we're going to have 7 to the negative 3. Okay, we can do that here in just a second, but we'll deal with that here in a second. And that would be y to the 6th. Okay, all over 2 to the 6th power, x to the 6 times 6 is 36. So now, we will have to move this to the bottom. Okay? Now, 7 to the 3rd power. 7 raised to the 3rd power would be 343. We're going to have to move that to the bottom. Oops, I'll get it wrong. That's 343 times. Okay? We have y to the 6 still up top. Okay? Now, 2 to the 6. 2 raised to the 6th power is 64. Okay? Times x to the 36. Okay? Just now, anytime it gets real complicated, let's make sure we have 6 to the negative 3rd. We made it positive, moved it to the bottom. We still have my y to the 6. I have my 2 to the 6, and I have my x to the 36. Okay? Now, the only thing we have left to do is multiply 64 times, what is that, 343? Okay, it's a big number, 21,952. Okay, we also have x to the 36 on the bottom. Okay, and that's on the top. All we have is y to the 6. Okay, and we have a, looks like a quotient rule. Let's take care of the coefficients first. 35 divided by 7. 35 divided by 7. Okay, that's 5, or 5 over 1. Now with the quotient rule, we'll talk about, okay, we have like bases, a's. Where's the a larger? It's larger on the top. So when we subtract the exponents, it's going to stay on the top. That'd be a to the 8 minus 3 is 5. Okay, so that's gone, that's gone. Okay, b to the 4th. Okay, over b to the 4th. 4 minus 4 is 0. Anything to the 0 power is 1. Okay, so that's gone. Okay, and then we have c's. Okay, it's larger on top, so it's going to stay on top. Okay, 12 minus 2 is 10. Okay? And we actually have nothing on the bottom, or I could just put it over 1. So we have 5a to the 5th, c to the 10th. Okay. What's always true? Now, what I would do here is I would, first of all, find out what this side is. Okay, we have a to the 6th, or a to the 2nd raised to a to the 6th. Okay, multiplying like bases, add the exponents. That's a to the 8th. Does a to the 8th equal this? Now, can we even add these together? No, they're not like terms. Okay, so this will not be true. Here, same rule. X to the 4th times x to the 5th, that's x to the 9th. Does x to the 9th always equal x to the 20th? No. Okay. Right here. Are those like bases? No. Okay, so this one would be x to the 3rd, y squared. Does that equal x squared, y to the 3rd? Does it always work? No. Can you make it work? Yes. If you put in 0 or 1, that would be true. But if you put in something else like a 2, that would not be true. Okay? Or a 2 for x and a 3 for y, that would not be true. Okay? So then the last one, x to the 5th times x to the 7th. Okay? Multiplying like bases, add the exponents, that would be x to the 12th. Okay, does that equal? Okay, we're raising a power to a power. What do? We multiply the exponents. 3 times 4, that would give me x to the 12th. Does x to the 12th always equal x to the 12th? Yes, it does. Okay, so there's my answer. Okay, here, which one of these expressions equals a to the 10th? Okay, let's just go through my rules real quick. A to the 8th raised to the 2nd power, raising a power to a power, multiply the exponents, that would be a to the 16th. No. Right here, power to power, multiply the exponents, that would be a to the 25th. No. Power to a power, 10 times 1 would give me a to the 10th. That's what I was looking for. Let's just go ahead and make sure. Here, we're multiplying like bases. What do? We add the exponent, so that would equal a to the 7th. We're good there. There's page 2. Hopefully that helps you out.